Hello, BC Calc. To all four of you who will want to watch this. Again, remember these are those optional videos if you want a brief refresher before we come back to school on a couple of the topics we covered right before Thanksgiving break. I hope you're enjoying your break, or you enjoyed your break if you're watching these to study for our test. So the first one I want to talk about are definite integrals with substitution. So when we did U sub, right, we always dealt with indefinite integrals, not with definite integrals with limits. And we had this idea of how we could replace the limits if we wanted to evaluate it that way. So let's suppose that we were looking at some integral. Let's say we're going from x equals 1 up to 2 of, say, 4 minus 3x to the 8th dx. Okay, well, clearly here, right, we want to use U sub because foiling that out would be awful, right? And so, it's fairly obvious right here that we're going to have u is going to equal 4 minus 3x. Okay, and I just want to highlight one thing, right? I was very explicit here. I said x equals 1 as these limits, right? We didn't always have that. Sometimes we said just from 1 to 2. We're saying x equals 1 because that's going to matter later. Okay, so if u is 4 minus 3x, right, then du dx is negative 3, or dx is negative 1/3 du. Right, you just solve for dx there. Divide by negative 3 and you get something like this. Well, we can then therefore rewrite our first integral, and I'm going to purposefully we'll write these limits from x equals 1 to 2, even though that won't make a lot of sense. So this 4 minus 3x to the 8th, that just becomes u to the 8th, and the dx, of course, becomes this negative 1/3 du that we have, right? So just quickly rewriting, that's from x equals 1 to 2 of negative 1/3 u to the 8th du. Okay, and so now we sort of had these two options, right, where I could either plug in, I could either evaluate this integral and then go back to x world and just keep my limits the same, or I could make a substitution. Okay, so we're going to do both of those ways, but let's first do it with a substitution. So these, again, this limit here, this is if x equals 1. Well, if x equals 1, we need to figure out what u is, right? So if x is 1, well, then u equals 4 minus 3 times 1. Because remember, u was 4 minus 3x. 4 minus 3 times 1, right? So u is just 1. Similarly, if x is 2, u is going to be 4 minus 3 times 2, which is negative 2. Okay, so now we can rewrite our integral. With our substitution change, right? We can say this goes from u equals 1 to u equals negative 2 of negative 1/3 u to the 8th du. And if this isn't setting off alarm bells in your head, right, then we might need a refresher into what this actually means, right? This is the area under the curve from 1 to negative 2, right? That's going backwards. So what we always want to do when we see that, right, is flip the limits and make it negative, right? So I'm going to have negative the integral from u equals negative 2 to 1 of negative 1/3. That's a bad 3. U to the 8th du. Okay, well, these negatives are going to cancel, and we'll see where we end up. Okay, so let's get this out of here. So we're going to end up with these negatives going away, and let's actually integrate this, right? This is going to be 1/27th u to the 9th. Oops, don't want that anymore, right? We don't have an integral anymore if we actually integrate this. Right, so this is what, 1/27th u to the 9th, because again, these two negatives cancel, evaluated at u equals negative 2 to 1. Well, of course, that is just negative, that's 1 over 27, right? 1 to the 9th over 27, we'll say 1 to the 9th over 27, minus negative 2 to the 9th over 27. which is going to be 1 over 27 plus 512. So we're going to have negative, because negative 2 to the ninth, of course, is going to be negative 512. So this is 513 over 27, or I believe that's 19. Yeah, it looks like that's 19. Okay. So that's what we got if we do change the limits. If we come back up over here, just to show you that we get the same thing, right? So again, this original integral was the area under the curve 4 minus 3x to the 8th between 1 and 2. When we make our u substitution, our limits now have to go from 1 to negative 2, right? So our width now becomes 3, and we studied those pictures in class, right? You can graph these on Desmos if you'd like. It's still the same area, right? We're just making it, we're looking at a wider range of a different curve, right? 4 minus 3x to the 8th is the same as, from 1 to 2 is the same as the area under 1 to negative 2 of negative 1/3 u to the 8th. Okay, so going back up here, if we wanted to keep this expression in terms of x, this expression up here, right? This expression, if we wanted to keep this in terms of x, right, we would have integrated the same, right? We'd have integrated the same, and we would have said, oh, this is really negative 1 over 27 u to the 9th, evaluated at x equals 1 and 2. All right, well, that's problematic because we're not in terms of x. So then we would have to make this sub, where we'd say, oh, this is really 4 minus 3x, evaluated at 1 and 2. Right, and then we would end up getting the same thing, right? We would say this is negative 1 over 27 times, plug 2 in there. Oops, there's a 9th up here. Plug 2 in there, we get negative 2 to the 9th minus 1 to the 9th, right? Minus 1 to the 9th. And since everything's negative, right, it's going to end up canceling. It's going to end up also being 513 over 27 or 19, right? We'll get the same answer either way. So feel free to watch this as many times as you want. I know it's riveting stuff. And I'll throw up a couple problems from that section in the book should you want the practice going in. But this isn't a topic that I feel like we need to spend too much time on because it's relatively normal. All right. I hope that